Okay, so lesson 4, table 1, or table 6 actually. So we have a computer costs $800. It loses a fourth of its value every year after its purchase. Write an equation representing the value V of the computer T years after its purchase. And then in order to type in your answer the right way, it wants you to use a slash for fractions, a caret for exponents like that, and only parentheses for multiplication. Lots of instructions there, but typing it in the exact way it wants will mark it right. So based on the description, would you say that it follows an exponential pattern? Or would you say it follows more of a linear pattern? Would I get each year after year by adding or subtracting the same amount each time, or multiplying the same amount each time? All right, well, if you can't answer that, then let's think about it logically. So let's start at year 0 and pretty much send the mode just below. Constant. Okay, so sorry, wasn't working on that one. Okay, so if you can't answer that, whether it's exponential or linear, just based on the description, then you have to probably think about it logically, make a table starting at the $800 it started with, that would be year 0, and then see what the answers are for each additional year after. So if it's losing a fourth of its value each year, what's a fourth of 800? Right? 2, 4, 6, 8. So yeah, you could split it into fourths that way. So if it's losing 200, how much does it have after 1 year? And then it's losing a fourth of its current value. So like now I need a fourth of 600. What's a fourth of 600? So you could do 600 times 1/4 in your calculator. I'm doing just 600 divided by 4 because 600 times 1 is 600. 600 divided by 4 is, okay, 150. That's what it's losing. So then I'm doing 600 minus 150. I'm kind of taking it back a few lessons to like what a lot of people would commonly do to get the next answer. And then it's 450. What's a fourth of 450? Okay, and then that's what it's losing. So then you'd have to subtract it if you're doing it this way. So now let me subtract it. 450 minus 112.5. And at year 3, it's worth 337.5. Okay, that's probably enough to figure out the pattern. So would you say that in the Y's, it's decreasing by the same amount? Like, is it minus 200 each time? Okay, so it's not following a linear function. So then I should probably use my exponential function as a setup. And that setup has me identifying my initial amount, because that's what A is. Initial amount. What is my initial amount in this? So that's going to be the first thing I type in, 800. It's going to be multiplied by a common factor. And remember what we talked about earlier. Common factor is what you can multiply by this number to get the next number. It's not going to be 1/4 because you already did that earlier. That's not the value at year one. That's just what it lost. If it's not clear to you what you could multiply by 800 to get 600 or whatever numbers you're comparing, take one of the numbers, divide it by its previous number. What's 600 divided by 800? 0.75, which it wants fractions. The equivalent fraction to that is 3/4, which those could also tell you, I can show you that in a second, but 3/4, right? Because if it's losing 1/4, you're basically plugging it into the 1 minus r. So what I'm actually multiplying by each time is 3/4. Hopefully that makes sense. Just explain it. And then it's going to be raised to the power of, let's see, what does it want me to use? It wants me to use the letter T. So that is how I would type it to get it completely right. I think it will still accept 0.75. I'm not sure. Let me see what answers it will accept. But definitely don't put in any extra spaces. If it gives you certain variables to use, don't use other ones. So let's see. Okay, so that's one way to write it. Let's see. And then they have the slash going the other way, should still mark it right. If you put the decimal, it should still mark it right. If you put the decimal without the 0 in front, should still be right. This they even included 1 minus 0.25, because that is true. That's how we got 0.75 is by doing 1 minus 1/4. And let's see how else you could have written it. This. I'm surprised they didn't include the 1/4 as an option, but that's basically it. Questions on that? Yes. Questions on other questions? Or any question. Could be from lesson 5, could be from any practice. And you need an attempt on this one? Okay, so number 3 on lesson 5 now, if you'd like to follow along. So the graph shows the amount of a chemical in a water sample. It's decreasing exponentially. Find the coordinates of the points labeled A, B, C. Write them in coordinate form and make sure you include the parentheses. And the only way to really know exactly, because not all of these are on a perfect little grid line, it would have to be by making the equation, which you do have enough information to do that. So exponential functions have what set up? What's their equation? I don't know, look at your notes. Look at the notes online. But in order to be successful at this, you need to know what your standard equation is for exponential functions. So just like how linear is y equals mx plus b, what's exponential? AB to the x power. A stands for what? Initial amount. Based on my graph, what is my initial amount? 1,000. Because initial amount will also end up being your y-intercept for one. And for two, we talked about how like whatever time frame, 0 is when it starts. So that x being 0, that y is your initial amount. B is what you're multiplying by in the y's to get the next number. So if you don't like looking at it like this, make it a table. So here's my first coordinate. You really only need two. If it told you already that it's decreasing exponentially, I just need to figure out what times 1,000 gives me 800. Honestly, even for me, that's hard to think about. So I can kind of work backwards. What's opposite of multiplying? So I'm going to take only have one possible number I could pick, but you usually take a number, divide it by your previous number. And that will give you your common factor, what you need to multiply by. And I said I would show you, but then I didn't. But here's what it would look like in Desmos. So I took a number, divided it by its previous number. So 800 divided by 1,000. And if I want the decimal should work just fine. If I want the fraction simplified, then it's 4/5. Okay, I'm going to use the decimal 28. But now for whatever x value, which the x values you can see clearly for each of these coordinates that it's asking about, all I have to do now is put this in my calculator and change the x value. Does that make sense so far? So then for point A, I know that has an x value of 2. So I need to plug it into this equation that we set up based on what we know about exponential functions. And the exponent's going to be a 2, because the function is 2. So that first coordinate is going to be 2, 6, 40. Make sure you have the comma in the middle, no extra spaces, the parentheses, and that's what you're doing for each. Do you think you could try B and C? If you still have trouble, let me know. But that's it. You just gotta be able to set it up and then change the x value to whatever. All right, other questions? Any questions? Let's try to question 2 on the lesson. This lesson 5 to you. Okay, so a population P of migrating. Okay, so number 2 on lesson 5, a population of migrating butterflies satisfies the equation shown there, where W is the number of weeks since they began their migration. What's the vertical intercept? Write it as a coordinate with no spaces. So what's another word for vertical intercept? All right, so anyone can answer. What's another word for vertical intercept? Y-intercept. So looking at my graph, what's my y-intercept? So it's 100,000 because it has 5 or 3, 4, 5 zeros. Okay, but that right here is your y-intercept. It wants it written as a coordinate with no spaces. So this is what it would be, 0, comma, 1, 2, 3, 4, 5. Close parentheses. All right, don't put an additional comma for the 100,000 because that's confusing when you're writing coordinates. The only comma that should be there is the one separating the x and y. All right. Then it says about when does the butterfly population reach 50,000? So here's where it says population of butterflies. Here's 50,000. And it said about when. So like three, looks like 3 weeks. For some reason it wasn't loading earlier, so I can't check my answer key, but did someone get this one right? Are these the answers? Okay. Yeah, but that's it. Questions on others? Might have time for one more depending on how fast it is.